All right, some of us were have been asking some questions regarding the chemical reactions we've been doing in class. We've been doing writing reactions, balancing reactions. The balancing aspect hasn't been that difficult for most of us. It seems like if you're having difficulties, it's actually more in the line of actually writing the reaction. And writing the reaction is only difficult because of the naming formula writing aspect that we should be responsible for. Okay, we've had this for many months. Basically, we have a hard time coming up with the formulas and also recognizing the seven diatomics. Okay, the seven diatomics is really, we've been doing that also for months, but it's really easy for a lot of us to kind of skip over and not see. And if you mess anything up on these formulas when you're writing the reaction, then a lot of times you can't balance them. Okay, so here's my diatomics. So I'm just going to pick them sporadically and do a couple here. All right, so those are my diatomics. I'm actually going to erase that. Okay. The first thing I would do, if you're having issues recognizing those diatomics, is actually read a couple of these questions and see if you can identify them. All right, number 2, aluminum bromide and chlorine gas react to form aluminum chloride and bromine gas. The first thing that should jump out is that chlorine is diatomic, bromine is diatomic. Okay. Reading number 2, sodium phosphate and calcium chloride react to form calcium phosphate sodium chloride. No diatomics. Potassium metal reacts with chlorine gas. Diatomic. Combined to form potassium chloride. Aluminum and hydrochloric acid react to form aluminum chloride and hydrogen gas. Okay, hydrogen gas is on our list of 7. Not so bad, okay, just identifying those 7. And hopefully once you identify them, you'll get better at spotting these on the fly. But, we just went through 4 of them and identified them. This way, when we actually do these 4, maybe we don't get slipped up to actually, misplace what we're doing here with the diatomics and just say Cl, just say Br. Now we know we're dealing with Cl2, Br2, Cl2, and H2. All right, now let's actually write these. Aluminum bromide. Like I said, I've told a lot of us that perhaps it's better to actually do some of these formulas on a piece of scrap paper. And this is going to be my scrap up here. Aluminum bromide. It's not AlBr. In order to be neutral, it must be AlBr3. All right, it's an ionic compound. You just have to write the formula. And chlorine gas react to form, that means arrow, aluminum chloride. It's the same thing up here. Aluminum chloride is a Cl minus 1. And bromine gas. Okay. Once you actually write the reaction, then it just turns into a balancing game, and that typically isn't as difficult. Okay, but first you have to come up with these formulas and identify the diatomics, and that's what we have so far. All right, my next move is to balance this, and my aluminums are balanced. My Br is a 3 and a 2. Lowest common multiple between a 3 and a 2 is a 6, meeting at 6. All right. My ALs and BRs are now, my BRs are balanced. I messed up the ALs, so I'm going to put a 2 here. And that gives me 6 CLs, so I'm going to put a 3 here. So I have a 2, 3, 2, 3 situation. All right, and now I'm completely balanced. You can double check things. 2 ALs, 6 BRs, 6 CLs. 2 ALs, 6 CLs, 6 BRs. So we're balanced. Can't reduce them. Full numbers. Perfect. Excuse me. Okay. Onward to number 3. Sodium phosphate If you don't know what a sodium phosphate is, if you don't get the formula correct, you're never going to be able to balance this guy. All right? What is the formula? Why are you guessing and just putting Na and P or whatever, or NaPO4? Well, no. The formula, again, is based on the charges. Plus 1, PO4 for phosphate, minus 3. Na3PO4. Plus calcium chloride. Okay, I'm just going to get rid of this just so we don't get distracted. Calcium chloride. Okay, it's not just Ca and Cl. It's CaCl minus 1 plus 2. That's my scrap. So it is actually CaCl2. React to form. To form means products now. Calcium phosphate. All right. Ca3PO4. That's a parenthesis. Not easy to erase here. 2. And sodium chloride. NaCl. Okay, I didn't write if you wanted to see how I derived the formula for calcium phosphate, it's plus 2. Really having problems here with the technology. Phosphates, PO4, minus 3. Okay, so I have my 4 compounds and their formulas are written correctly. Now comes the time where I actually have to balance it. Okay, and you can start with anything you want. I can already spot that you're going to run into problems if you just start with the NAs. All right, and you can do that, but you're going to have to erase. If I start with the NAs, I'd put a 3 over here. But then I'd actually end up moving that up to 6 and have to erase things. I'm going to start with the phosphates. I have 2 phosphates over here. I'm going to put a 2 here for the phosphates. Then I'm going to move over to the sodiums. 6 of those. I'm going to put a 6 here. Then I'm going to move over to the chlorides. I have 6 there. I'm going to put a 3 here. Then I'm going to do calciums, and they're already balanced. Okay. If I was going to do the sodiums first, that's perfectly fine, but just know that you're probably going to hit a brick wall, and you're going to have to work your way out of that jam. Okay, you're perfectly able to pull that off, but there's going to have to be some erasing. Typically what I do, if I fall into a trap or a dead end, it's the best bet if you're having difficulty is just erase all those coefficients and start over and start with something else. Okay, so if I did start the sodiums and I didn't like where it was headed, I could erase it and then maybe do the phosphates or the calciums. Potassium metal, K, plus chlorine gas. We already said that was Cl2. Combined to form, that means arrow, potassium chloride. Potassium chloride is K plus 1 Cl minus 1. Okay, so it's just KCl. And to balance this, K's are wells, Cl's I need a 2 here, which means I have to fix my K's with a 2 there. And I'm balanced. Again, the balancing is usually fairly simplistic. Writing the formulas, which we've been responsible for doing now for months, is where some of us are having difficulty. Aluminum and hydrochloric acid. Aluminum, hydrochloric acid. Hydroblankic acid. Hydroblankic acid. Okay, our hydro acids are binaries. I'm going to use this area up here for scrap. Binary hydrochloric is an H plus 1. Cl for the chloric, chlorine, minus 1. It's just HCl. React to form, arrow, aluminum chloride and hydrogen gas. Well, I might as well put the hydrogen gas down first. Okay, order is not important. Aluminum chloride, All right, we've actually done that up here. It's AlCl3. Again, how did I find that? Al plus 3. Really having difficulties with the tablet right now. Cl minus 1. AlCl3. Okay, nasty looking 3. Starting here, okay, first of all, aluminum plus hydrochloric acid yields hydrogen gas and aluminum chloride. I did it out of order, and that's fine. I have my 4 chemicals, my 4 compounds written correctly. Okay, 2 elements and 2 compounds. Now it's time to balance. And I have 1 aluminum, 1 H, 2 H's. Okay, I could put a 2 here. But I'm already looking ahead to the CLs, and I know that I have to now squeeze I'm going to have issues with let's just do it. I'll put a 2 here. Everything's balanced but CLs. I have 2 CLs and 3 CLs. Okay, which means they're having issues. Okay, so I'm going to have to meet at 6. I'm going to put a 2 here, which gives me 6 CLs. Which means I'm going to have to turn this into a 6. My H's now need a 3, because I have 6 H's, I need 6 H's. And then my aluminums need a 2. Okay, that one's, you ran into a little brick wall. We did the same thing if we had NAs, if we start with NAs in number 3. But that's okay, we worked our way through it. Again, I gave you a couple tips on balancing. It seems like we're doing relatively well on the balancing. A lot of it is just kind of a guess and check, and we survived it. I would say the biggest problem that I see some of us having is just not writing ionic compounds properly. And, you really have to take responsibility for that and really come see me or come get help from some other source, because you're definitely, responsible for that, and you have been responsible for that for many, many moons.